Hello everyone. Today we are looking at simplifying rational functions that corresponds to 2.4 in your textbook. So rational expression is the ratio of two polynomial expressions. So you have a polynomial in the numerator and another polynomial in the denominator. Given polynomial expressions p of x and q of x, a rational expression has the form of this: p of x over q of x. Again, numerator is a polynomial and denominator is another polynomial. But where q of x is not equal to 0. So the denominator cannot be equal to 0, because if the denominator is 0, then the expression becomes undefined. A number cannot be divided by 0. You get undefined for that. A rational expression can be simplified if there are common factors in the numerator and denominator. Let's say we have x minus 3 times x plus 2 over x plus 2 times x minus 1. So we can simplify this. So you get x minus 3 over x minus 1. However, when you simplify, you should not forget to say or determine where the denominator is undefined. Okay, so when you look at this, we call it restrictions. Okay, whatever makes denominator 0, we call those restrictions. So in this case, x plus 2, so denominator becomes if one of these factors is 0. Okay, so you get x plus 2 equals 0, x minus 1 equals 0. So when x equals negative 2, denominator becomes 0. And when x equals 1, denominator is also 0. So you can express this rational expression as x minus 3 over x minus 1. So you can simplify it like that. However, you have to state the restriction saying that x cannot be negative 2 and x cannot be 1. Okay. So then it is asking, are the original and simplified expressions equivalent? If you just say x minus 3 over x minus 1 as a simplified form of this, so they are not equal. Okay, make sure to state the restrictions so that you can use a simplified form of this. So no, if you write it like this. Okay, so these two are not equal. Uh, so where you simplify, if you state the restrictions, then that is fine. Okay, a restriction occurs when a factor in the denominator of the rational expression evaluates to 0. Okay, so again, you look at all the factors in the denominator, and whatever makes denominator 0 are your restrictions. So x equals negative 2 and x equals 1 makes denominator 0, and therefore those are our restrictions here. Okay, so then you say restrictions are negative 2 and 1. So let's get some examples. Simplify each expression. So A, and we are also going to state the restrictions. We have 24x cubed plus 6x squared plus 12x over 6x. When you look at the numerator, we see that 6x is a common factor. If you factor that out, you get 4x squared plus x plus 2. Okay. So before you simplify, make sure you state the restrictions. So in this case, if you take 6x and make it equal to 0, you get x equals 0. So restrictions, x cannot be 0, because when x is 0, then denominator is 0. So now you can simplify, but make sure, again, you have the restrictions. So 4x squared plus x plus 2 is a simplified form with the restriction x cannot be 0. Let's look at B. So we have x over 4x minus 2x squared. Again, if this factor, so 2x is a common factor in the denominator, you get 2 minus x. Okay, so before you simplify further, state the restrictions. If you take the denominator, I'm going to do the work here. And make it equal to 0. This is 0 either when x is 0 or when x is 2. Okay? Okay, when x is 2, as you see, 2 minus 2 gives you 0. Or when x is 0, this whole thing becomes 0. So restrictions are 0 and 2. So now you can simplify x and x. We have the same factor. So you get 1 over 2 times 2 minus x with the restrictions 0 and 2. Let's look at C. We have 3 minus 2x over 2x minus 6. You see that 2 is a common factor in denominator. 3 minus 2x, 2 times 2x minus 3. Now, when you look at 3 minus 2x and 2x minus 3, actually they have the same terms, however, they have opposite signs. Therefore, 3 minus 2x and 2x minus 3 are called opposites. So if you multiply one of them with the negative 1, you get the other. Okay? So if I then factor out the negative sign from the numerator, you could do the same thing with denominator, doesn't matter which one you prefer. So 2x minus 3, 2 times 2x minus 3. Now you see that we have the same factor in numerator and denominator. So you should be able to recognize those opposites. So you will keep seeing those, in this chapter. Okay. So now we can actually write the restrictions and then simplify. So you take the denominator and make it equal to 0. Okay. So 2 is never 0. So what makes 2x minus 3 0? So I'll do the work here. 2x minus 3 equals 0. So you get 2x equals 3. X equals 3 over 2. So when x is 3 over 2, denominator becomes 0. So which is your restriction? The restriction is x cannot be 3 over 2. Now we can simplify and we get negative 1 over 2 with the restriction 3 over 2. Let's look at D. We can factor numerator. So x plus 3, x plus 7, and denominator is x plus 3. Again, state the restrictions before you simplify. So denominator is x plus 3, make it equal to 0. So you get x equals negative 3. So x cannot be negative 3. So now you can simplify and you get x plus 7. With the restriction x equals negative 3. E. Again, let's factor numerator and denominator. So you get x minus 4 times x minus 5. And in the denominator, if this is difference of squares, you get 4 minus x times 4 plus x. Now again, you should be able to recognize the opposites here, x minus 4 and 4 minus x. They have the same terms, but opposite signs. So you can factor negative sign either from numerator or denominator to make those factors the same. So I'm going to factor negative from the denominator. So you get x minus 4. And that is x plus 4 or 4 plus x, doesn't matter. The order of those doesn't matter. Okay, so now you can write the restrictions. So x cannot be 4 and x cannot be negative 4. And you can simplify now x minus 4 and x minus 4 and never leave the negative side in denominator and move it up. Move it to the numerator. So negative x minus 5 over x plus 4 is the final answer, of course, with the restrictions for 4 and negative 4. Let's look at f. Again, the first step is factoring numerator and denominator. So if we factor numerator 5, 1, negative, positive, so negative 10x, positive 3x gives you negative 7x. Okay, now let's factor the denominator. 5, 2, so negative, positive. Positive 6x minus 5x gives you positive x. Okay, now state the restrictions. Again, you take each factor, make it equal to 0, and solve for x. So 3x minus 5 equals 0, gives you x equals 5 over 3. X plus 2 equals 0, gives you x equals negative 3. So restrictions are x cannot be 5 over 3 or negative 2. And now you can simplify, and you end up with 2x plus 1 over x plus 2. Okay, let's look at G. We see that 2 is a common factor in this bracket. So I'm going to take the 2 out. 2 times negative 3 gives you negative 6. So negative 6, 2x minus 1. And denominator is the same. Okay. Now you can simplify the numbers. 6 and 8. They give you negative 3 and 4. Okay. And before I simplify the other part, I'm going to state the restrictions. So if you take 2x plus 1 and make it equal to 0 and solve for x, you get 1 over 2. So x cannot be 1 over 2. So if x is 1 over 2, again, so this becomes 0, and then denominator becomes 0. Now simplify 2x minus 1 and 2x minus 1 square. So you get 2x minus 1 in the denominator. Okay, so let's look at the last example. We have 2m square minus mn minus n square in numerator, and 4m square minus 4mn minus 3n square in denominator. Let's factor numerator. Okay, so this one will get negative, that will get positive. So negative 2mn plus mn gives you negative mn over, let's factor the denominator. I'll try 2m and 2m. So one is going to be 3, the other one is going to be 1. So let's say then negative 6mm, and this is 1n. Okay, so negative 6 plus 2mn gives you negative 4mn. Okay, now state the restrictions before again you simplify. So if you take each factor and make it equal to 0, so 2m plus n equals 0, you can isolate m or n from here. So let's say we isolate m. So we get 2m equals negative n, m equals negative 1 over 2n. So when m is equal to negative 1 over 2n, so this factor becomes 0, and then the whole denominator becomes 0. Okay, so that is one of the restrictions. So let's look at the second one. So 2m minus 3n equals 0. Again, isolate m from here. 2m equals 3n. M equals 3 over 2n. Again, if m is equal to 3 over 2n, this factor becomes 0. Therefore, the whole denominator becomes 0. So restrictions are m cannot be negative 1 over 2n and 3 over 2n. So now simplify. So we get m minus n over 2m minus 3n. And you see here the practice questions from your textbook.